Today we are going to talk about exponential function. Now, what is exponential function? You may have or you may not. You may have encountered exponential function in your differential calculus way back, your 11th grade? Or during your first year college. It is this a lot of times, and most of the students hated this problem because they get confused on solving exponential function. Now we have this, and it is pretty common in solving it is pretty common in integral, so you will encounter this a lot of times. Now, for the question, how are we going to solve the exponential function? Now we have a simple formula, one formula. We have here e raised to u du, that is is equal to e raised to u over u prime, or the derivative of u as you may call it, plus some constant c. Plus some constant c. Now let's try some examples. I have here e raised to 5x dx. So remember, this is our u. So we need to apply this e raised to 5. You copy the exponent, and then you get the derivative of the exponent. So what is the derivative of 5x? That would be 5 plus some constant c. Is this clear enough to you? Because if it's not, you need to go back to your differential calculus and recall some techniques in solving derivatives. Okay, I have here another problem. What if I have e raised to 7x minus 3 dx? Later would be e 7x minus 3 over, what is the derivative of 7x minus 3? Now I say derivative even though we have this, because the formula says e raised to u over u prime, or the derivative of u. So we get the derivative of the exponent. So what is the derivative of the exponent? That would be 7 times 1 plus some constant c, or we can rewrite this as e 7x minus 3 over 7 plus some constant c. Alright, so that is clear enough. Now what about, I have here, what is the derivative of e raised to 2y minus 400? What could that be? dy. What could that be? So the answer would be e raised to 2y minus 400 over, what is the derivative of 2y minus 400? That would be 2 plus some constant c. Pretty easy and pretty fun, huh? Now what if I have the derivative of e x squared minus 1. Oops, the x with respect to x, of course. What is how are we going to integrate this one? The same thing, we follow the rule. Don't get distracted by the x squared minus 1. Don't get distracted. Let's just follow the rule. E x squared minus 1 over, what is the derivative of x squared minus 1? That would be 2x plus some constancy. Again, if this is not clear to you, you need to recall your differential calculus. Okay, what if I have this tricky question? What if I have this tricky question? This is pretty tricky. What if I have f of x is equal to e sine pi over 5? How are we going to integrate this one? Now, in this problem, you need to be extra careful. How are we going to integrate this one? What do you notice? You notice that this is a constant. This is a constant. That is constant. Why? We don't have any variable x, so that means this is a constant. So don't worry, don't get distracted by e sine pi over x. Maybe you started already solving this by a logarithmic, or by taking the integral of this and then this. No, the answer would be as simple as this: x e this is sine pi over 5 plus some constancy. And that is the answer. Ask me why. Because you got distracted by e sine pi over 5 that you didn't notice. We don't have any variable x here, so that means this is a constant. So in integrating constant, we need to add, we simply copy the constant and then add the respective variable. It's either e, y, z, or depending on the given problem. So that is how you integrate exponential functions.